So when you open Unity, yours will probably, it'll give you like the kind of startup window saying like, do you want to watch the tutorials and blah, 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 blah. But beyond that, one of the first things we're going to do with all these things is start a new project, right? Because essentially what happens with Unity is, when you do these projects, you're going to have like meshes and animations from other programs, scripts that control behaviors, materials, particles, all this sort of stuff. And I mean, the cool thing about Unity and how it ends up working much better is, at the end of the day, what actually happens is it compiles all of this into like a packaged working video game. So at the end of the day, you're going to just end up with like an exe file that you just run the processing thing, and it's done, which is what makes it a lot more kind of robust than the other ways you can do it. I mean, yeah, you can connect data into anything, and for a long time, sensor data, connect data, you can fake it into Rhino, you can fake it into Maya, and get stuff to move around. But it's not really what it's meant to do, so you can't do very much. One of the other kind of very cool things of doing it through Unity is, if you think about, modeling software where you can get the data into, Rhino or whatever, those are programs that are all made for you to make something and render the result, right? So it's made to be like, here, now make an image of what you want. The thing about Unity is it pulls all the kind of graphics potential, but it does it real time, right? I mean, you think about video games are fairly advanced of, texturing, lighting effects, physics effects, particle effects. It means that you can interact with these things and get that sort of quality, so some kind of video game quality, working with it in real time, right? So you're actually getting a much kind of more interesting and cleaner output than you would otherwise. So one thing that's probably different when you open yours, it probably looks more like this. So I'm going to go ahead and start a new project. So I'm going to say new project. Doesn't really matter where you save it locally. You'll notice though, there's all of these kind of, it asks you what packages you want to import by default with the new project. It's not a big deal because anything you don't import at the start of the project, you can add them really easily later. One of the ones that we're going to add for sure is always going to be the character controller. Today we're not dealing with particles, but later, like tomorrow or the next day when we start looking at kind of interactive particles, you'll add the particles package. But for today, you can just get away with the character controller and the physics materials, right? So those two you definitely want, because the character controller is, basically what's going to let us, turn these new little objects that are being controlled by the Kinect into a character, and the physics is going to let us know collisions, right? So what we're going to be basically like, have you hit me, yes or no, right? So that sort of functionality is built into the physics materials. So then I'm just going to create the new this. It'll then kind of restart the program if you already had it open, and sets up the environment. So basically what happens is within the kind of project, all your sort of different tests and things can become different scenes. So you can have lots of setups within one project. So this is kind of where you should get to. This view, I think you can click the grid on and off with that. But it's just like a modeling environment view, right? I mean, it's, scroll to zoom. It's actually really similar to Maya controls if you're used to that. So Alt, left button is pan, right button is zoom. and you can also use the scroll wheel. And what's important to understand is this isn't a modeling environment at all. Like, you make the content somewhere else and just bring it in. So one of, actually, we'll just start it there. So you'll see me, and I kind of suggest this because it makes it easier. I tend to set mine up where if you go to this view where it's the game tab and drag it down here somewhere, and that's how I leave mine set up. It'll become more apparent why here in a minute, because basically what these two views are, this is the sort of setup view, whereas the game tab is what you would actually see in the kind of compiled game. So that's related to the cameras you have set up in the scene and everything. So the game is at the end of the day what you're going to get, but this would be the setup I'll have, and I'll suggest you do the same. So what I'm going to go ahead and do is then go to, I'm going to do it with Maya, make a really simple object, and bring it in. So, like I said on this thing, like I said previously, if you have models or whatever in Rhino, just export them and bring them into Maya. So the one thing we're going to talk about within Maya, and like the reason why you wouldn't go directly from Rhino, everything in video games happens in polygons. That's just what makes the world go round. Like, so you're either going to, if you have surfaces in Rhino, you're either going to convert them to polygons when you import it into Maya, but one way or another, it has to be polygonal surfaces, just because that's what game engines understand. So to start with, I'm going to just use a kind of normal polygon primitive. I'm going to use a torus, so click on it, and just drag it here. Can be anything, it really doesn't matter. And actually, you know what, we're going to go all in with this. So first thing I want to do is when I go to move it, so you can do the move command or W, and I'm going to turn on my grid snap, because I'm going to snap it to the 0, 0, 0 in Maya. Even if you import something from Rhino, you want to move it to the kind of origin point in Maya, because once it imports into Unity, that's its origin point. So it looks at it in terms of the kind of maximum origin in Maya. So if it's like sitting over here somewhere, it's going to treat that as its origin rather than its actual center point, and it gets to be a nightmare to position things. So you want to start with whatever you've got, put it at the origin. And what I'm going to do here is I'm just going to make a really simple animation of it rotating. Yeah? So to do that, if you're not used to dealing with Maya, this is, I'm going to flip back and forth. You've got the channel box here, which is the kind of attributes of the object, and our time slider at the bottom. Right now, we're viewing frame 1 to frame 24. We're going to give ourselves a few more frames than that. So I'm going to give myself like 100 frames. And for this first one, we're just going to do just a simple keyframe animation. if you're not used to keyframing stuff, it's, all you're having to do, like if I was going to do, if you think about like old school animation, like if I was doing an animation of a cup moving across the desk, like in like old school like Walt Disney animation, you like draw an image of it there, and then draw an image of it there, and then draw an image of it there, and then draw an image of it, right? Where with keyframe, you just say, at this time, the cup sits here. At another time, the cup sits here. Now figure out everything else in between, right? So you define the key frames, it kind of interpolates the values between the two. So I want to do something super exciting, like make this thing rotate 360 degrees. So to do that, I'm going to start it on frame 1. So frame 1, you can also define the frame here. And the value I'm actually going to be changing is going to be the rotate X. So if I could do the move command or hit E for the hotkey, I can rotate it, and you can see over here the rotate X is changing. The important thing to remember with keyframes is the order you do it is you change the time, then change the value, and then set the keyframe. So we're on frame 1, and what I'm going to do is I'm just going to highlight the rotate X and then right click, hold down right click and say key selected, and you can see it turns orange saying it saved that keyframe. And then I will go to frame 100, so highlight here and type in 100. And at that point, I want it, I know I want it to go 360 degrees, so I put in 360. And then I highlight rotate X again and say key selected. So now, when I go into my time slider, if I just drag it, it rotates. And pretty much all of the, one thing to kind of, you notice, 360 degrees, it's kind of starting and end point is a loop. And that's, a lot of times that's what all sort of video game animations are based on. Like, just because if you think about like the example from like the character before of like the animation of that character walking, it's not like, you don't know how long a character is going to be walking forward. So you design the animation to loop on itself, right? So it's to kind of complete one cycle and then just keep playing the animation over and over and over again. So same thing here. It's starting and ending at the same spot. So there we go. And again, I can also see it if I hit play. Super exciting. All right, so next thing to do, there are a lot of different ways to kind of export it from Maya to get it into Unity. We're going to stick with the kind of format that we can use for everything. So the format we're going to export as is FBX, which is a kind of standard format between animation, game, whatever files. So to do that, actually I'm going to save my Maya file first. So I'll save the scene. I'll call it rotating ring. And then I'm going to go to export all. And down here I'm going to choose FBX. And when I do that, on the right, you'll get all these options. And I'm going to run through the right things to use here. So the good news is, like, once you set the options once, it pretty much remembers them the next time. So you shouldn't have to do it every time. So you want both of those to be right, so the default file extensions and actually preserve the references. Then under the include, for what we're doing, none of that's going to matter. under animation, you want that checked. So like when it exports the file, it also knows like, all right, here's the animation or animations that go with it. We also want to tell it to bake the animation for us. Our animation goes from 1 to 100. So that's the right frames. In the future, this will be more important. So having where it's clicked for the deformed models with the skins and the blend shapes. That doesn't matter. And then damn it. Yeah, that should get it. So sorry, the one thing it was missing, because when I scrolled, it switched it from the FBX export here. Out of all, the other thing that's important is the file format, and you want to switch it to FBX 2011, just because that's more, I don't know, it might work well with 2012, but everything with Unity says use FBX 2011, so it'll be fine. Yeah. So just use whatever if you've got my 2010, just use whatever the newest version of it is. And I've got 2010 on here and it works fine. So okay, so now I'm just going to export my file and I'm going to call it ring1. And that's that. So now I'm going to go back to Unity. And the way it always works, you have this tab over here called Project, and then this, which is the hierarchy. Since it's a game, lots of things work off of kind of repetitively used assets. So you kind of bring everything into a kind of library, and then you can kind of drag in as many duplicates of that as you want. So to add something to our project, you go within this tab and right-click and say Import New Asset. And then I'm going to go to, well, there it is right there, wherever you exported your FBX file to. And I'm going to say Import. So when you do that, you'll get these sort of, on the right in the inspector, you'll get these import settings. First thing you want to do is on the scale factor, switch it to 1. Otherwise, just things get too tiny. Then at the bottom, or as you scroll down, there's this tab called Animations. And there's nothing in there now, but there's a little plus sign. So I'm going to click the plus sign, and it pops up this thing, gives a default name of idle. We're going to call it rotate. And then it wants to know, like, where is the start point and the end point of the animation. Like, I know from ours, we made ours go from frame 1 to frame 100. Later on, where things have multiple animations, you just define them in the Maya file. Like, all right, animation 1 goes from frame 1 to frame 100. The next one goes from frame 101 to whatever. The next one goes from there to there. So in this case, we're going to say 1 to 100. And then in its wrap mode, we're going to put it on loop, right? So by default, it's a kind of cycling animation. Then get down to the bottom and just say apply. So now you'll see in our project we have this new guy called Ring 1, and it has, you know, underneath it the geometry and the animation that's associated with it. So to actually use anything, you have to drag it into your scene. And there's two ways to do it. You can drag it in directly here, or what I tend to do is just to drag it over to the hierarchy folder, because by doing it that way, it means that it puts it at the origin. So it's much easier to kind of drag it and say you're at 0, 0, 0, and then move it around than for you to just drag it into the scene and it kind of picks where your closest point is. So just drag it in. And you can see now that in my game view, it's already started to show up. So there's two different things. The game view, for us, we're going to stick with mostly one camera. And you can see when you make it, there's always this kind of main camera view. And I want to kind of focus in on those. So the hotkey for kind of zoom extents is F. F is in frame. And now, you know, it zooms in and you can see my camera object, right? So just like you would do it if you were rendering, setting up a camera, like this camera is basically the view you're going to get when you play the game live, right? So in the same way of whether it's attached to like a person or like a first, you know, where you're looking from, that main camera is what you're going to get at the end of the day. And if I pick it either here or in the scene and I move it, you can see in my kind of game view it's changing, right? And that's why I would suggest putting them together, because a lot of stuff of kind of lining things up, it's easier to see that. And it's the same thing, you know, I can rotate it. You know, move it away. I'll put it like there. The other problem you'll notice is that it's just completely black, and that's because there's no light. You know, it doesn't make a sort of default light like in other things. So you have to actually put the lights in. I will say as well, like when you click on the camera, you'll see that it has a lot of the pretty much the same settings like you would see in any program, like the sort of aspect ratio of the camera, what's its kind of far and near clip plane, all these sorts of things. So first of all, I want to make a light. So to make a light, you can just go over here directly in the hierarchy, and there's the create drop down. I'm just going to say create, and I want to say a point light. And when you do that, like, it shows you, like, I've got the point, and then it has its sort of sphere that it actually affects, right? So which is the kind of maximum fall off of the light. And as I move it around, you know, you can see it in the kind of game view as well, what that's going to result in. And the properties of the point light, you know, you can change them over here, where intensity of it, the range of it, you know, all the normal stuff, really. What I'm going to do, I'm going to pull it a little farther away and then just click the range up. You can also just drag on the point, like when you pick it, you can just drag this little point to make the range larger. But, you know, that's good enough for now. We can actually see it. So the first thing I'm going to do when I pick the ring, you can see its kind of normal attributes, like its XYZ position, the rotation, the scale. one thing that it doesn't, you can also see that it knows it has an animation called rotate. And for right now, the box called play automatically is checked. And what that means is hopefully when I hit the play button up here, and the play button in Unity is actually a lot like processing, where that actually means compile everything and test it. So when I hit play, it rotates, right? Because what it's done is taken all the kind of disparate parts and compiled them together into your first video game, right? So, of course, where we're going to go from now, which is the kind of basics of pretty much everything we're going to do for the next couple of days, is instead of just saying, all right, rotate all the time, like the first thing we'll do is say, only rotate, like only play that animation when something hits you, right? So if someone collides with you, play your animation. If not, wait. Simple enough? All right, so to do that, we're going to need two things. So for right now and for testing, we're going to just make a sort of dummy object in Unity that we're going to use that's going to represent our kind of object that we're going to be controlled by the connect. Because basically what's going to happen is we're going to make those XYZ points that we were grabbing from the processing sketch. We're then just going to connect it to the pieces in Unity, right? And say, you know, these are your XYZ coordinates. So move around. The real crux of the situation, though, comes from how do you know if you've been hit? Right? How do you know? And like I said, the basic thing we're going to use are colliders or collision spheres or capsules or whatever. So to give something a collision trigger, like I'm going to pick it here in the hierarchy, and I'm going to go, and then I'm going to go under component, physics, and then you'll notice I've got box collider, sphere collider, capsule collider, and then these others. These three are going to be basically the ones we use. So, and it just talks about like, okay, what sort of shape makes sense for the collision of this object, right? So I'll look at a couple different ones first. So we'll start with just a simple sphere collider. So I'll pick the sphere, and you can see that it's now drawn this sphere around it. And that represents its collider, right? So it now knows, has any other object in the scene gone within the shape of that sphere? Yes or no, right? It's just a kind of Boolean thing. Also, when we added that to it, it showed up in its inspector. So it's the sphere collider, and it has a radius. If we want it to be bigger, you know, you just change that number. Right? So it can be bigger than the object. It has its own set of XYZ coordinates as well. So, you know, if I pick, you know, if I moved this, you know, the collision sphere doesn't have to be on top of the object. Like when you make it, it defaults on top of the object, but you can kind of move it to wherever you want. So you could say, you know, even though my trigger is out here, I'm affecting the object over here. Make sense? So they don't have to be over the top of each other. They can be, but they don't have to be. So obviously, with a sphere collider, that's what you can control, right? You can make a radius, and you can make a position. I'm actually going to go back and show you. So what about the other collider? So I'm going to do the same thing. I just did Control-Z and got back to undoing it. So component, physics, and say a capsule. When I do a capsule, at the beginning it looks exactly the same. And again, you can see it made the capsule collider. But it obviously has two properties, right? It has a radius and a length, right? So if you think about the actual like geometry of a capsule, you can control it more than you can a sphere. So for this, I'm going to leave the radius the same, but I'm going to make its height, instead of like 2.6, I'm going to make it like 20. Or we'll call it like 100. And the other option here is what axis you want the capsule to go in, and I actually want it to go in the Z. Oops. Yeah? So now, even though the object itself is only this big, you know, it projects out into the Z its collision. So like if your kind of virtual object is sitting here, you know, in terms of thinking especially about looking at like the surfaces, it's sitting here, but you can kind of extend the capsule of it all the way out. So if anybody walks anywhere within that, it's going to trigger it because it knows it's connected. So that's sort of step one. There's one other actually really important point, is anytime you're making a collider on what we're doing, you need to do the checkbox that says is trigger. It doesn't do it by default, but for everything we're going to do, you're going to want that turned on. So next, I'm going to make just kind of a default object that's going to represent eventually like one of our connect joints coming in. And to do that, I am going to use one of the Unity primitives, and I'm just going to go into the create, and I'm going to say create a sphere. And already my camera gets a bit annoying, so I'm just going to scale it. It's the same hotkey as Maya, so R gives you scale. I'm going to move it out so I know that it's not colliding with it. So pick a ring, its collider goes there. I know it's not. I know it's out of it to start with. So now I've got just, again, basic geometry, just dumb geometry. So for the objects are the kind of passive or receiving, the responding objects, let's call them, of whatever you model. Everything you do on there, they're going to get a collider, box collider, sphere collider, capsule collider. You know, anything you model, that's what they're going to get. You're going to add the kind of collider trigger to them. Any of the objects you're using to kind of as the input from the connect are going to get a character controller. Just as thinking of it that way. So it's basically taking you and your data and turning you into a virtual character. Right? So it's, again, just kind of using the kind of video game engine on itself, because that's how they work, right? There's objects in a scene that are driven by a digital character. The difference is, instead of like doing it with a kind of joystick or something, like you're just becoming the sort of digital character, or multiple people. So to add that, pick the sphere or whatever object you made and go under God, I always forget. So again, component, physics, and character controller. So the same menu where you added it, but you're going to give it a character controller. At first, you're going to get this warning about replacing the existing component, and just say replace. It only asks that because, like, when it makes these kind of default objects, it gives them a different collider. It doesn't matter. Just say replace. Right? So now when you click on your object, you have this new thing called the character controller. And it has these options that we aren't going to deal with. Again, the kind of XYZ of its collision sphere and its radius and height. So I'm going to make it a little bigger just to make sure we hit, right? But you can think of them this way, right? Like input, output, right? Character controller is the input. The collider is the output. It's going to know, have I been hit by a character or not? It's obviously possible for other objects to know lots more, but for what we're doing, this is going to be plenty. Like, have I been hit by this character? So, all that we're missing now is the little bit of code that says, if I'm hit, what do I do? Right? So, luckily for you guys, I've written a couple of just like the basics that get you most of the way. So to get those in, we're going to go back to our project and right-click again and say import new asset. And you're going to go again that first that workshop files zip file that was from the website. Go into there. So same way we were looking at the processing files, only we're going to go into the Unity folder and scripts, and there's a folder called animation trigger, and you're going to select animation trigger basic. And then once you do that, it's going to show up in your project. So here's animation trigger basic. So the question becomes, how do you then apply that sort of general script to the object? It's a very complicated process of you pick it and you drag it over the top of it. So I'm going to drag it onto ring. Yep. So then now when I select ring, it has this new little section down here called animation trigger, and there's one thing here which is called, there's the script, and then there's this well, this one's actually not labeled right, but it's called idle animation. It doesn't really matter. And then basically all it wants to know is, what animation do I play if I'm hit? Right? So the way you define that is go into here and click on the little circle, and it's going to open this select animation clip, and all you need to know is like, what was the animation called? If you remember, I called it rotate. And that's it. So the only other thing we need to do now is go back and click on ring and uncheck play automatically, right? Because we don't want it to play automatically. I just want it to play when I've been hit by something. And so it's like, wait for it, then if you're hit, then play your animation. And how this script's set up is, this one says, if I'm not hit, don't do anything. If something is colliding with my collision detection, keep looping the animation, right? So if something is being hit, is hitting it, as long as it's there, it's going to keep playing. As soon as you move out, it stops it at that last point. So now we're going to test it. So to do that, I hit play. So you can see now nothing's happening, which is what we want. I'm just going to, in the scene view, pick my sphere and move it over. It hit it, now it plays. I move out, it stops playing. Yep. So here's the fun bit. And this is why this program is really good fun. So one thing I'm going to do is I'm going to pull my camera even farther out. And move this thing off the screen a little more. So one of the really powerful things about how this thing works is, okay, we have a very basic thing set up, right? Like, I am here is a sort of, here's a single file we've brought in, given it this, we've attached a trigger to it and said, if you're hit by something, play your animation. The way the program's set up is, okay, that's one of them, but if I want to say try it with a lot, all I have to do is go to Ring, right click on it, say duplicate. Now there's another one. I move it over a little bit. Then I'm going to duplicate that one. And then I'm going to duplicate that one. And then grab them all, duplicate those. Then I'm going to grab all of those. Anyway, that's probably enough. So, cool thing is, the way the program's set up is now every one of those has the same behavior. So you don't have to add anything else just by simply copying it. And the way it triggers it, it's all kind of local knowledge. So any of those that are hit now behave in exactly the same way. So if I now play it, move my sphere around, yeah. And the whole thing, like that's it. Like if you do another one, you just keep copying them. Because since it's all based off of triggers, it's just a kind of local input, right? It doesn't, in these sort of scripts, it doesn't care who hit it or why it hit it or where it hit it. It's just like you build it into their like local brains. If you're hit, play. And what's interesting here is, you know, it now becomes important, more important, you know, less about the kind of actual programming of it and thinking about, all right, what sort of shape of collision makes sense? How big should it be? How much does it overlap with its neighbors? Where is it in relation to the object? How big is the input object? Because, you know, obviously my character collider is kind of small. If I make it bigger, that's a little too big. You know, I didn't change the script, I just changed the volumes. I just changed the geometry of what it's looking at. Does that make sense? Like, this is the basics of everything we're going to do. You know, you can have more inputs. You can have, you know, more inputs, more interesting things than just stupid toruses, more interesting animations. We can again, we'll look at, you know, animating lights, particles, or whatever. But this is the idea that you can model some content, set up a trigger, and have it be hit by something. All right, so there's one more small piece of the puzzle, and then we're going to take lunch. So obviously the only thing we're missing here is, well, the connect, right? But I'm not actually going to change anything here. All I'm going to do is add one more layer that says, instead of me moving the sphere around, attach that sphere to the position of one of the joints that it's tracking. Or in the case of like the earlier ones, when it's just like the passive one. So if you see a person, it's recording their XYZ position, right? Like just when you notice it, like you walk past the camera, it picked up a person. Well, as soon as it picks up the person, it has the coordinates of their centroid. So all it says is, you know, attach the character to that character. As they move through, it just attaches. Question?
Yep. Is it possible to modify the script of one of those rings, but not affecting everything else?
Not when you duplicate it. There's other ways to do it where you can do it that way, but this was just like when you just duplicate the one thing.
And I cannot just use that as a basis and just kind of modify it a little bit. Like so, for example, like one ring will be rotating the other way, and then just...
You can do it. You just do it a slightly different way.
Oh.
Yeah, it's not a big deal. It's just the way it's set up now. There's obviously like the positives doing it both ways. I mean, the advantage is here you can change the script and affect. If you change the single script, it affects the whole system. But yeah, you can have it where they're different as well. It's not a big deal. So the question becomes, how do we get the data that we had in processing into Unity, right? So I'm going to go back to, I'm actually going to use the one that just says skeleton server. So while that's coming up, in Unity, again, we're going to go under our project tab and right click. And this time we're actually going to say import package and then custom package. Then go to the same folder where we got the script from, so the kind of workshop files folder. And so then go under Unity, and then go under servers. And I'm going to use the one that just is called Connect Skeleton Server. It's going to point this out. It's going to say prefabs, blah, blah, blah. Those are both great. And say import. And now it made this new folder called prefabs, and then underneath it there's this thing called Connect Skeleton Server. And when I click on it, you can see it has the kind of attributes built in that basically just lets it port the data that processing is calculating to just an attribute, right? So all the things it tracks, head, neck, left shoulder, elbow, hand, torso, and then just XYZ, right? So that's just what's going to hold the data that processing is figuring out. The other thing that's important is on the multiplier. It defaults to 10 because the actual pixel data, it runs from like 500 to like 3500. So what 10 is just saying is it's just dividing everything by 10 just to kind of keep it in a little smaller area. So you don't have to work with like a scene that goes from 500 to 3500. You can go from like 50 to 350 or whatever. And you can adjust that as you go along. So to use it, I have to do, it's still only in my library. So to kind of add this to the program, I again just have to drag it in. So I'm just going to chuck it in the scene. You obviously don't see it because it's not like there's no geometry. It's just a server. And now is where it gets tricky for having such a small screen. Do it down here. That'll work. So I'm going to hit play to start the scene. Go in here. Oh, sorry, did it backwards. There it goes. Right. So same little things that it's seeing per those XYZs are now just routed to this object in Unity that has the values. So what I then want to do is be able to tell a sphere or basically any object, look at one of those joints and follow it. So to do that, again, we're going to go back into the project and say import new asset. And go in the scripts folder. And yeah, go under skeleton track, and there's joint position connection is what that stands for. So just import that. So we've now have this as a script. Again, so then we go through this very complicated process. So we're then just going to take that script, drag it onto the sphere, and now at the bottom, you can see that the script's now there. And then the only question is, like, what joint do you want it to follow? Right now, it defaults to the head, but you just pick. So I'll stick it to my torso. And then hit play. So this is why I say it's all about kind of weird calibration, right? Like this is what as much of it is like one person kind of standing and moving stuff around. Damn it. Yeah. Right? And again, I was just like, there's the little depth offset, depending on, it's just like the Z depth thing of like just setting your 0 point. Right? So now I'm triggering it. And obviously as well, like the problem is right now the even though they look big, like the capsules aren't long enough. So generally just make them really long, right? Because the advantage of doing it is the capsule is in kind of profile, it fits so they don't overlap, but then you just extrude them out into space. So you basically hit anything. Make sense? So let's all have lunch. And like I said, the goal for the day, which I think is, you've already done the hardest part of this, honestly, which is getting all the stupid drivers to work. Basically by the end of today, everybody should have it to at least here. Yeah, actually, preferably something more exciting than rotating donuts. Something about the coffee makes a person, model rotating donuts.
It would be a perfect animation for a coffee.
Yeah, exactly. But makes sense. So, I mean, this is the logic of it. And obviously, right now that's just the one sphere. I could keep. That's attached to the torso. All right, I'll show you one more thing. So let's say, you don't want to just track a sphere. Let's say you want one of them to be on your hand. Well, we're going to go to the sphere. We're going to duplicate it. No, sorry, I lied to you. I'll make one fresh. So I'm going to delete it. So I'm just going to create another sphere. Add the character controller to it, and then I'm actually going to rename this, which is always a good idea. I'm going to call this one and hit. And then all I need to do here is I need to connect it. So I'm just going to, again, drag the kind of joint position connection on top of that. Change it to like right hand. And I also want to make its radius much bigger. So make its radius like 10. And now there's two of them, right? Somehow managing to not hit anything. Anyway, it's there, I'm just not managing it. So especially after lunch, we'll talk about like, okay, how do you get through these things? And basically a lot of what you do is just kind of slowly work backwards and figure out where things are supposed to be. Because like right now the problem is like, where is my torso? So, it's also good, like a good way of calibrating this stuff is actually to do it by your feet. So you can just, if I just say like, track my right foot, and then when I pick the hand, oh God, you can see it up there moving it. So it's tracking my right foot, and also in the top right, even though it's a bit too squished, like that's giving you the XYZ coordinates of where you think it is, right? So basically what you do with these things is you start to figure it out, right? You start to just like, all right, here's point 1. Write down those XYZ coordinates. You then just make an object, type in those XYZ coordinates, and make like a marker, right? Like, this is where I'm at. Then you go over here and say, this is where I'm at. And again, once we start moving to the gallery, again, where the tiles get really useful, because it just like, it is your grid. Like the same grid you have, in the scene, so that's what the tiles become. So you just like can mark out, all right, the collider exists, you know, here. You know, put a piece of tape down, so you know that's what you do. All right, that's enough.